So today we're just going to be kind of finishing up some odds and ends that I want to make sure that we're good for. We have the whole first page done, correct? Including the bottom. Talking about that when warm air, what's warm air do? What's it do? Warm air. Where's warm air go? Okay, warm air rises. Why does it rise? Because, and what temperature is it? Or what does that warm air cause it to do besides rise? Like, what do the molecules do? They expand. And when those hot, sweaty molecules expand, they then cool off. So that's what we got at the top. That's great. Did we do anything on the pressure side? That's where I think we're lacking here. Did we do what? Okay. All right. So we did a little bit, and that's just where I want to catch up from then. So we're on page 25, and I'm just going to start from the top of page 25, even though it looks like most of you have a lot of 25 done. So we're starting with, well, what is air pressure? So we talked about this. If I asked you just to tell me what plain old regular pressure is, or if I asked you to put pressure on something, what would you do? If you were, yeah, you push down on it. CPR. Yes, that's a good way. You push down on something to apply pressure. Air pressure is the same idea. It's just the air pushing on you. So I think we already wrote that air pressure. I think we wrote this already. The air pressure is the weight of the Earth's atmosphere, and it changes depending on temperature. We did this already. So what did we talk about with temperature? Do you remember? I remember pushing on Sarah's shoulder, I believe, right? Oh, Kat's shoulder this time. What was the cough? So why did I push down on Kat's shoulder? What was I representing when I pushed down on Kat's shoulder? Which kind of air? Cold air. Cold air. Why cold air pushing down on Kat's shoulder? Does cold air stink? So if I'm pushing down on Sarah or Kat's, wow, I really wanted to push on Sarah's shoulder, apparently. So I was pushing on Kat's shoulder because I was cold air. Is that going to be a high pressure or a low pressure then if I'm pushing down on Kat's shoulder? High pressure, just like if you were to put a lot of pressure on your arm, you'd be pushing down on your arm. Then warm air comes through, and what does warm air do on Kat's shoulder? Yeah, it rises up. So instead of pushing down and putting a lot of shoulder pressure on her shoulder, I'm pulling up and there's less pressure on her shoulder. So temperature will control the pressure. We use a barometer to measure this. We label that. Yes. Yeah, we filled that in, and a barometer will measure pressure in two different ways. Either inches of mercury or millibars. So that looks like the last one we got, right? Now remember weather maps, these, where are they? Where the weather maps? I thought I had, they're right, here's one. Remember these guys? Oh, yeah. Yeah. To connect the dots for slightly older kids. Well, here's a pressure one. And does anybody remember what these lines are called when they connect areas of equal pressure? They are called isobars. So that's the next thing we got to show on there. Isobars, they're the lines that connect places of equal barometric pressure. By the way, when you see barometric pressure, you can just think air pressure. So the next thing I want to show you is a good old fashioned mercury barometer. And this barometer is not, it's not the most high tech situation there is out there. But it is how barometers work, even if they're a little more advanced than the one I'm about to show you. So here is a dish of mercury. In that dish of mercury, we put an upside down test tube that's labeled in inches. Yes, the same inches that are on a ruler. First of all, do you guys know anything about Mercury? It is a planet, yes. It's a type of metal. So yes, Mercury is a planet. It's not what we're talking about though. Yes, we're in a little snow globe. So that Mercury is a planet. That's not what I'm talking about when I'm talking about Mercury. I'm talking about the metal Mercury. What else do you know about it? Yeah, it melts at a really low temperature. In fact, at room temperature, it's a liquid. So it's a metal, just like metals, but it's liquid at room temperature. So it's this ball of very thick, metally liquid. It's actually quite cool. Yeah.
Is it like an element?
It is an element. Mercury is also an element. Yep. Mercury can cause brain damage and actually cause people to go crazy. Yeah.
Ooh.
Yes, so we can get to that. So, do you guys know the Mad Hatter in Alice in Wonderland? He was mad, not an angry mad, but mad like crazy. Because apparently when you made hats back in the day, you used mercury. Not gonna lie, I have no idea what you could have possibly used mercury for when making a hat, but apparently they did.
Not even possible.
What? Oh, insulation? I'll take your word for it. I have no idea. I have no idea what they use mercury for. So that's a good theory. Maybe you know more than I do, but the mercury was used to make a hat. So that's why the Mad Hatter was crazy, because he got brain damage from using the mercury and he went kind of crazy. That is why they do talk about not eating, especially if you're pregnant, you don't want to eat too much fish that could potentially contain mercury in it, because again, you could get that mercury poisoning. That was just a side story, not important for this. I guess it is important because you won't find something like this out there again. So it's a dish of mercury that's liquid at room temperature. It's really thick, so it kind of stays in a glob. And we put this test tube in it. It's very sensitive. So when the air is pushing down, and by the way, when does air push down? When it's cold. So the cold air is going to push down on this dish of mercury. And where is the mercury going to go? Up the tube. If that tube wasn't there, it might just overflow. But in this case, since the tube is there, it's going to push down on the mercury and it's going to go up the tube. That's when it's pushing down, cold air. Now warm air comes along, and what does warm air do? Instead of pushing down, it pulls up. What's going to happen to the mercury in the tube? It's going to go down, and that's going to be a lower pressure. So that's where they get the inches of mercury from. So I do want you to write how this generally works. I'll be honest, if you're the type of person who doesn't like to copy absolutely everything I tell you to do, these two last bullets are the very important part of this. So the first part talks about the mercury barometer, but the second part is the moral of the story. Cold air sinks. If it's sinking, we have higher pressure and the mercury rises. Warm air rises, which means lower pressure, and the mercury sinks then. Like I was saying, if nothing else, make sure you definitely get those 2 bullets.
Yeah, Alden.
Good. Maybe star, highlight, underline the last 2 bullets there. It is important that you understand that cold air sinks. That sinking is gonna give us a higher pressure. And it's gonna cause the mercury to go up the tube. Okay, we're gonna go to the last part for pressure here, and that's using the conversion chart. It says using the pressure conversion chart on ESRT page. Anybody remember what page you might find that on? Not 14, 13. It's the one that I gave you, or Mr. D got you, the enlarged version. The enlarged version will absolutely come in handy for this, just like it did for the temperature one. So if you have that, go ahead and grab that enlarged copy. If you don't have the larger one, obviously the smaller one in your reference table will work too. It's just not quite as easy. So this is right next to, so this is where we were working the other day with the temperature conversion chart. And now we're gonna come over here and work on the pressure conversion chart, which works the exact same way with just a different set of numbers. I'm doing my high-tech zooming in here, so it's a little bit larger. So we got, again, here's the pressure chart. Like I was saying, works just like the temperature one. Now on the temperature one, they were over here, they told us when water boils, room temperature and water freezes. Over here, they just have one separate label that says 1 atmosphere. 1 atmosphere would be like the average pressure. So anything above that 1 atmosphere, that's going to be high pressure. Anything below that's going to be low pressure. Maybe let's add that. So here's the 1 atmosphere. Anything up here is going to be considered a high pressure. And everything below that 1 atmosphere would be considered a pretty low pressure. And then the only other thing we gotta do is kind of talk about what they're going up by, just like we talked about on the Celsius and the Fahrenheit one. So I think it's easiest to start on the left here, millibars. Let's pick one random that's labeled. I'm gonna go with this one. 1020.0. The next line that's labeled is 1024.0. There's 1, 2, 3 lines in between. What are they going up by? They're just going up by 1s. Here is 1020, 1021, 1022, 1023, 1024. So the millibar side is going up by +1. So I did add that label right there. The other side, however, is a little bit more sketchy. 0.01. So here's what we mean. Here's 30, and there's 30.1. So there's not much space in between those, but there's 9 little blanks. And Zach is right. This is going up by, and I'm going to enlarge this. So there's the 30. The next line up is going to be 30.01 and then 30.02. If you don't need to write that, you don't have to. But again, this side's going up by 0.01. So you do just have to be careful what that side really is. Let's try converting these back and forth, just like with the temperature one. You find whatever you're looking, or whatever they give you. So the first one they give us is 29.06. Do not get that confused with 29.6. That's a different number. We're looking for 29.06. Where is that? There's 29.0 and there's 29.1. So 29.06, 0.01, 0.02, 0.03, 0.04, 0.05. Notice the 0.05 is definitely larger we're going one line above 29.05. So we're going right there. 29, no, we're not. Right there. What do you think that number is?
94 point.
So is it right on the 984? No, it's just a smidgen above that 984, just a teeny tiny bit above. So what do you want to call it? That works. 984.1 works for me. 984.2 would have been 5. 984.3. What about 984.5?
No, I don't think it's there yet.
No, definitely not up to that halfway in between the two lines. Let's do one on the other side of the chart. Let's do this 1011. Where's 1011 on here?
One tick below the 1,000.
That's a perfect way to put it. One little line below the 1012. So go over, what do you think that one's on? 29.85 works. It is a little bit, if you have I can tell on this one, I don't know if you can tell on the real one. Nah, it looks like it's pretty much right on. I agree with that. Where are we? 29.8 is here, 29.85 is right up there. I would like you to do the remaining 6 on your own. So call us over if you need a little bit of help reading this. If anybody wants another one of the enlarged copies, if you didn't already get one, I have some spares up here. Larger one. I didn't already give you one. Anybody else want the larger one? Okay, get going on those remaining 6 versions. So, oh, you all set? Yeah, I wanted to do it.
Yeah, I'm all set.
Okay, you're all set, good. Just to go through these pretty quickly, I think I checked most of everybody. They looked great. I had 1014 right on the dot for this one. If you said it was slightly over, I think it does look a little bit over on the small one, but when you have the enlarged one, it looked dead on. This one, I had 1033 for the third one down and 997 for the last one in that side. Anybody have any huge discrepancies? You good with those? On this side, we already did the first one. Then I had 30.15, then 30.56, and then 29.26. You got them all exactly. Aren't we amazing? Did anybody have something you're not sure if you're good with that one? Because it would be okay to be off by a little bit, but not very much at all. Like, which one? Instead of 26? Well, let's double check it. 991 would be right there. I'm wondering if you miscounted because it definitely lines up perfectly with the 0.26. There's 0.225. Wait, which one are we doing? This one right there. Yeah, it's lines up perfectly. One line above the halfway mark. All right, then, if you have no questions, let's talk about this last part, which is a graph. You know, we've talked about this 100 times. The Regents love these basic graphs. We've already talked about pressure and altitude in the atmosphere. As altitude increases in the atmosphere, what happens to the pressure? Where can we find this answer? In your reference table. So why doesn't everybody find the answer in their reference table, please? It was on our last test, so please find it in your reference table. On page 14, you'll find our lovely little atmosphere graphs that we were using. And with these, remember, altitude was on the y-axis for this one, which is a little awkward. But as you can see, it does make sense because here on the ground, we have a pressure of just about 1 atmosphere. And the higher we go, the pressure gets closer to 0. That's slightly different than what they're saying here. So let's reread this. As altitude increases, so as we get higher in the sky, what happens to pressure? It does decrease. It starts at 0 on the, or 1 on the ground and gets close to 0 as you go up. But how will this graph look the way we've worded it here? As altitude increases, pressure decreases. Where do we put what? That's what I'm saying. We got to label it the way we wrote it. We did this in chapter 1 this year. September, maybe early October, but I bet it was September. Which one goes on the x-axis? Altitude. It's whatever is written first. So altitude goes here. Means pressure goes here. Now, if altitude increases, so this way is increases, what happens to pressure? It goes down. How do I draw that? That's a down line, yep. So it's saying when altitude is low, when you're near the ground, pressure is high. When you're way up high in the sky, pressure is low. Now here's what I want to ask. Does that make sense that there's less pressure as you go higher in the sky? Yeah. Why?
Because there's less of that science.
There's less of the atmosphere when you go up. The higher you get in the sky, there's less atmosphere pushing down on you. It's very similar to when you dive to the bottom of the pool. What do you feel? A lot of pressure. Why? Yeah, besides the whole drowning factor. Why is there a lot of pressure? Because all the water's pushing down on you. And you can't breathe. So while it's different because we were talking about going up in the atmosphere versus going down in the pool, it is also, they're both the same. It all depends on how much is pushing down on you. So when you go higher in the atmosphere, there's truly less atmosphere pushing down on you. So we do not have much time, but we're gonna just get a little bit introduced to wind on page 27.
Wind blows, Sarah.
Wind blows, we got that, wind blows.
I know someone else said.
Guys, it was really windy the other day.
Yeah, it was.
It was crazy windy, like,
It made my friend's house shake.
yes, it definitely, there was definitely some shaking going on because that wind was excessive. Here's the thing about wind. So this, I'd like you to do this as one big bullet on the first line of the wind note. Wind is caused by the uneven heating of Earth's surface. We're at the very top of the wind on the very first line, right here.
That's right.
Yep.
So we're not doing anything.
So we are right now talking about wind. Wind is due to the uneven heating of Earth's surface. Let's think back to Saturday when it was so windy. Saturday night. And I'm telling you, it has something to do with heating. What were some observations you made during the day on Saturday when it was a little humid, okay.
At 2 a.m. my car went out.
It was kind of warm. For the weather we've been having, Saturday was quite balmy, in fact, Friday into Saturday. It was quite delightful. It was probably some of the nicest weather we've had in months.
Except for when I was.
also inside, gymnastics meets, whatever. Let's move on.
Yeah,
I'm not gonna dwell on that. So it's nice out. Let's talk about Sunday and Monday. It was cold out. snowing out. Wind is caused by an uneven heating of Earth's surface. You see that unevenness? Pretty warm and decent out on Friday and Saturday, cold and yucky out on Sunday and Monday. Wind is trying to even out that unevenness, basically sharing the wealth. We want to make everybody equal. Did you guys learn about equilibrium last year? The answer is yes, you did learn about equilibrium last year. Who remembers what that was all about? The world, the systems love to be equal. In cells, why does water go in and out of cells? Do you know like how it does that through diffusion?
Yeah.
Where does it go from and to? High concentrations of water to low concentration of water. Well, wind is the same way. So underneath that first bullet that you just wrote, and that was like the biggest bullet, we'll have some extra parts to this. So because there's these different temperatures, it leaves us with different pressure. Ryder, we're on page 27 of the packet. So we already established different temperatures give us different pressure. So remember, cold air sinks. So we have high pressure. Warm air rises, we have low pressure. So the different temperatures around Earth give us different pressures around Earth. And then, just like the water going through the cells, high to low concentration, wind will do the same thing. The high pressure gets blown to the low pressure. They like to share the wealth. And it looks like this is where we have to stop for today.